Hello AP Physics 1, it's Mr. Ng, and I wanted to walk through Chapter 4, Example 19. It's a very common type of problem that goes through a lot of the basic math. So here is example 419. It says that a 10 kilogram box is pulled along a horizontal surface with a force of 40 newtons. It uses force P for pull, I suppose, and an angle, a theta of 30 degrees. This is like example blah blah blah, and we know that the friction coefficient is 30. So let's just have all our variables out. So we know the mass is going to be 10 kilograms. We know that the force applied, they're going to use force P, I'm not going to stop them, is equal to 40.0 newtons. We know that that theta is going to be 30, right, degrees. And then we know that the friction coefficient, kinetic friction in this case, is going to be 0.30. And then they want to know what the heck is the acceleration. Okay, so from what we remember, we know that the friction coefficient, to find friction, is the friction coefficient times F normal. So we really need to find F normal, right? So let's draw a free body diagram. I know they kind of have a diagram here, but for me, a free body diagram, we know there's mg, we know there's going to be F normal, but these two are not going to be the same size because look, we also have this 30 degrees thing, right, where this is 40, and then this has to be 40 sine theta, if you kind of remember, like up and down is always sine. That means this is 40 cosine theta, right? So we should know that the two arrows up, right, the two up vectors should equal that one down vector, right? That's just the way it is. Normal force is going to adjust itself so that it just kind of evens out the gravity. And then that's how we find F of friction, Fr, and there you go. So here we have a free body diagram. Let's break it down nice and easy. So part one, we need to find F normal, right? To find F normal, we need to find the F net Y, right? Just along the y-axis. Does that make sense? Just kind of going up and down. We're not worried about going left and right. And we know that this is going to be equal to the F normal plus this thing. This is the FP, but just the y component of FP. And then minus mg, because, well, it's in a different direction. I'm just signifying up as my positive. And we know all of that is going to equal to 0, right? Because it's not moving. It's not flying up and down off the ground or anything. So that means that F normal plus FPY is basically equal to mg. That means F normal is equal to mg minus fpy. And now all we got to do is plug in. I think this is as simple as we could get it. So F normal is equal to 10 kilograms times 9.8 meters per second minus fpy is 40 sine 30. If you punch that sucker into your calculator, you're going to get 78 newtons. Hooray, hurrah. So we know that F normal is 78 newtons. Okay, good. So now we could use this equation. So now part two, right? Now we could find the F of friction. F of friction is the friction coefficient times F normal. We don't need to do any wacky math, then we just plug in right now. 0.30 times F of normal is 78 newtons. That means the friction is going to be 23.4 newtons. Hooray, hurrah. This is our F of friction. Good. So now, part 3, all we got to do is solve for A. So that's going to be pretty easy, right? This is a horrible free body diagram. Let's just reduce it down. So we have F pull, but on the X, minus F of friction, right? This is going to be our F net, and we know that F net is equal to MA. So our sum of forces, or F net, is equal to Fpx minus the F of friction is equal to mass times acceleration. To get acceleration by its lonesome, let's divide both sides by m. That means that A is equal to Fpx minus F of friction divided by m. And we know what all of these things are, right? Fpx is 40 cosine theta, F of friction is right here, and mass is right here, 10 kilograms. So acceleration is equal to 40 cosine 30 minus 23.4 newtons divided by 10 kilograms. If you put all of that in, you should end up with 1.1 meters per second squared. There you go. Big pieces of math that you should remember. I think the trickiest part is probably figuring out that F normal is not equal to just mg because there's another vertical component, right? The two up components should equal mg. Once you figure out what F normal is, then you could find friction. Once you know friction, then you just use Newton's second law to solve for A. I hope that's nice and clear for you. If you have more questions, please reach out. Thank you very much for watching.